Good afternoon, all. Myself, Assistant Professor Sagar Govind from MIT Academy of Engineering, Alandi, Pune. Today, I am here to deliver a session on vapor compression refrigeration cycle on temperature entropy diagram. So, for this topic, my topic of discussion are as follows: the introduction of vapor compression refrigeration system. Then, once we understand this VCR concept, then we will learn about how this VCR cycle can be plotted on TS diagram. And for this, I have taken four cases where the first case will be based on when the vapor is dry and saturated at the end of compression. Second, when the vapor is wet at the end of compression. Third case, when the vapor is superheated at the end of compression. And when the vapor is separated before the start of compression process. So with the help of these four cases, I will explain you about how to plot the VCR cycle on temperature entropy diagram. So let's begin. So introduction about VCR. So in a simple VCR system, there are total four working components, and these working components will complete one particular cycle. So if you observe here, the four major working components which helps in completing this VCR cycle are compressor, condenser, expansion, and evaporator. So this compression, condensation, expansion, and evaporation process will helps in completing or achieving one complete cycle of VCR, that is vapor compression refrigeration. Now let's understand how this process starts. So at initial to the compressor, the low pressure and low temperature refrigerant which is coming out of the evaporator will enter this particular compressor through this port, inlet port. And once it enters, the actual compression process starts where it gets compresses to higher pressure and temperature. And as soon as the compression process get complete, then this high pressurized, high temperature vapor refrigerant will enter into the condenser section where the phase change will take place to liquid state. So here the condensation process can be a water cooled or air cooled. Depending upon the situation, the type of condensation can be opted. So as soon as the high pressure, high temperature refrigerant enters the condenser, it starts changing its phase to liquid state. And this condensation process will take place at constant pressure and temperature. Means there will be no change in the pressure or temperature. And once it gets converted into high pressure, high temperature liquid refrigerant, that will be stored in the receiver where through this particular receiver it get processed through expansion wall, where in this particular expansion wall the expansion of that particular refrigerant will take place from higher pressure to the lower pressure side. And during this expansion process, drastic drop in temperatures also get noticed. And once this expansion process get complete, the low pressure liquid vapor mixture will finally enter into the evaporator where it will absorb all the heat which is stored in the evaporator section, and while absorbing this particular heat it will again change its phase from mixture state to the vapor state. So in the expansion process, the saturated liquid will change to the mixture phase, and in the evaporator section, the evaporator phase will change back to vapor state by absorbing the heat in this particular evaporator chamber. And in this particular evaporator chamber only, we will get the cooling effect. That is our main motive. So in this way, this cyclic process takes place and the vapor compression process will takes place. So once we understand this cycle, now let's understand how to plot this process on the TS diagram. Now before plotting, just I want to inform you that the compression process here will take place at adiabatic condition. Means here entropy will remain same. While the expansion process will take place at isenthalpic condition where enthalpy will remain same. Okay, so these are the important parameters that need to be kept in mind while plotting the process. Now we will take the first case, that is when the vapor is dry and saturated at the end of compression. So here the statement tells us that after compression, the state of refrigerant that we are getting is in dry saturated condition, that is dry vapor. So for that, our point number two, that is after saturation, our point number two, after saturation will lie on saturated vapor curve. Okay. And since the compression process is in adiabatic stage where entropy remains constant, so 1 to 2 is a straight vertical line. So once we plot the point number 2, we just need to draw a straight vertical line downward till the initial pressure. That is our point number 1. So once we get the 1 to 2 process, that is a compression process plotting has been done, then the next process is condensation process, where the condensation process takes place at constant pressure and temperature. And this condensation process will continue till entire vapor refrigerant gets converted into saturated liquid state. So that is why the point number 2 to point number 3 is a straight horizontal line. So this particular line indicates the condensation process taking place at constant temperature and pressure. And this process will end on saturated liquid curve. That is the point number 3. And once complete condensation process takes place, then the next process is expansion process, which takes place at isenthalpic condition, means enthalpy remain constant. And since we are plotting the TS diagram, so here 3 to 4 process will be a curved line. Okay, so it will be represented in the form of curve, which indicates the enthalpy lines on this particular chart. Okay, and this particular curve will be drawn till it reaches the lower pressure, that is the initial pressure. And once entire expansion process takes place, here we can observe that the saturated liquid state has get converted into the mixture state. And at this particular point, it will enter into the evaporator chamber, where it will absorb all the heat which was present in that particular chamber. And during this absorption, here the phase change will take place from mixture state to the initial state. That is the point number 1. Okay. So here 4 to 1 indicates the evaporation process. Okay. So in this way, we plot the process on the psychometric chart. And once we plot the process on the psychometric chart, then the next task is to find out the performance of this particular VCR cycle based on this particular condition. So for that, here you will find the description about what are the different process. Okay. So we can go through it. So for finding the performance of the system, we have the definition that the coefficient of performance is defined as the ratio of net reflecting effect divided by the work consumed by that particular compressor. So your reflecting effect is between the process of 4 to 1. So here we calculate the reflecting effect as H1 minus H4, where H indicate the enthalpy values. Similarly, the work consumed is between 1 to 2. So the compressor work is equals to H2 minus H1. And when we put these values in the equation, then our the COP equation will be H1 minus H4 divided by H2 minus H1. Okay, so in this way we can able to plot the process on psychometric chart, and once we plot the process, we get their parameter values from the particular chart, and through that particular values we can calculate what is the COP value. Okay, so when we refer this particular chart, once we get point number 2, through that we can get the H2 value and H1, and after that we can get the H4. How H4 we can be get? Because 3 to 4 is the isenthalpic process. So once we know the H3 value, we can easily get the H4 value. Okay, that is H3 is equals to H4. So in this way we need to calculate the COP and we need to plot the process on the TS diagram. So the next case is when the vapor is wet at the end of compression. So in the previous case, we have assumed that the vapor is dry saturated at the end of compression. So that's why point number 2 was plotted on saturated vapor curve. But in this particular case, the statement is vapor is wet at the end of compression. It tells us that after compression also the vapor is in wet condition. It means our point number 2 will not lie on saturated vapor curve. Instead of lying on saturated vapor curve, it will lie within the dome. Within the dome. So this is the dome. I just take a pen. So this is the dome. Okay. So this is the saturated vapor curve and this is the saturated liquid curve. Okay. So our initial point is here. So 1 to 2 is a compression process, and after compression also the state is in wet as per this particular statement. Okay. So once we get 1 to 2 process, then from this particular point only the condensation process takes place, and it will condense till saturated liquid state at constant pressure and temperature. So that is why we draw the horizontal line from 2 to 3, okay, till it cuts the saturated liquid curve. And once it completes the condensation process, then the expansion process will start, that is from 3 to 4, okay, where this expansion process will takes place at isenthalpic condition. And once an expansion process takes place, then the evaporation process starts, where it will absorb the heat from the evaporator region and regain to its initial condition, that is point number 1. Okay, so in this way the TS diagram for the second state, that is when the vapor is wet at the end of compression, is plotted. And once we plot this particular process on diagram, then the next task is to find out the performance. Okay, so here again the formula will remain same, that is the COP is equals to net reflecting effect upon the compressor work. So reflecting effect is obtained between 1 to 4 process, so that is why H1 minus H4, and work consumed by the compressor is between 1 to 2, so that is why H2 minus H1. So finally we can get the equation as H1 minus H4 divided by H2 minus H1. But here there is a point that need to make a note. That is, in this cycle, the enthalpy at point 2 is find out with the help of dryness fraction at that particular point. Means here we cannot get the point number 1 and point number 2 values directly from the chart. So for getting those particular values, we need to know what is the dryness fraction of the refrigerant during that particular state. Once we know the dryness fraction, then we can easily calculate the enthalpy values by using the equation. Okay, so this is the point that we need to make a note for this particular state of condition. That is when the vapor is wet at the end of compression. So that's all for this today's session. In the next session, we will learn about how to plot the rest two conditions on the TS diagram and how to calculate their COP. So if anyone has doubts till this particular point, they can let me know by contacting through my email or through WhatsApp. Okay. So thank you guys for your cooperation. Have a good day.